So I just hit stop recording. So this recording will be up in two different parts. I do apologize for that. I hit the wrong button with my fat fingers. So ethene is this. This is ethene. Sorry, this is ethane. Only single bonds. Carbon to carbon. Double bond. So we need to get rid of a hydrogen. So that will be ethane. If we wanted, sorry, ethene. This is now ethene because of this double bond. We could add another carbon. 3 more hydrogen. And we would then have propene. So if it was propane, we would just, so propane now, we to add in double bonds. That's something similar to that. And then butane, butene, butane, so on and so forth. So it's very similar, the homologous series. So we know that carbon can form single, double, and triple bonds. So you may have guessed already what an alkyne is. Shock horror, triple bond. So alkyne would be, so we might start with, again I'll use ethane, start with ethane. So ethane. This will now become ethene. It's got a double bond. We now go to triple bond. I mean, you can really represent this how you want it. So the same principles apply for the octet rule when you're looking at building these organic molecules. 6 being shared, 8, 8. So everything is happy. This would be ethine. Triple bond is ethine. So if we think about it alphabetically, so single bond, ane, comes first in the alphabet. Double bond is ene, comes second. Triple, ine, it comes third. Easy way to remember. So I hope you're looking at the slides when you're watching this. So, functional groups. This is the entire basis of organic chemistry for what you're learning and, at the moment. These functional groups give the organic molecules their properties. So, if we're looking at, so again, I'll come back to ethane because it's the easiest to simplest, terribly writing and drawing. Anything that requires artistic skill. So, for alkanes, the lack of a functional group is their functional group. So the lack of a functional group gives them their chemical characteristics. Ethene, this double bond here is the functional group because it gives the alkenes their chemical characteristics. And if we look at ethyne, this triple bond gives the alkynes their chemical characteristics. So, when we're looking at naming, so we're on slide 20 now. Alkenes, alkanes, and an ane. Alkenes and an ene, and alkynes in ine. And this is the simplest way to name things. There are other different ways, but this is the one that the Queensland curriculum follows, so I'm going to continue with that. So anes end in anes, enes end in enes, ines end in ine. Funnily enough, fairly self-explanatory. So, I mean, I've done this slide, we've gone through ethane, ethene, and ethyne. The difference is in how the bonding of the carbon atoms in the chain. So, again, anes come first because they are single bonds because they come first. Enes are second, so double bond. Ines come third, 3 bonds. Okay, so slide 23. So, if anyone watching, I'm just going to give 30 seconds to get ahead of me. I'll try. So, if there's a little bit of pause, you're watching the recording, it's intentional. Just have a think about what this could possibly be called. So, the first thing we should notice is the bond. It's a big, juicy double bond. So, we know that this is going to end in an ene. It's going to end in an ene. And again, for those playing along at home, how many carbons are in the backbone? How many carbons in the backbone? So it's 2. Ethane. So we have on slide 23, for those watching along, So, again, give 30 seconds to mull that over before I get into it. Okay, so again, we've got double bond. So 3 carbon. So this is quite simple. This is the simplest. It gets a bit more complicated when we have molecules with chains or branches. So slide 24 is what we're on now. These naming conventions work great when it's just a straight chain molecule. Lots of organic molecules have chains or branches, and it gets pretty tricky and not complicated, but you can easily trip over yourself and get it wrong. And if you keep up and you follow the same easy conventions that we're going to learn, then it demystifies it quite a lot. So 25, 1, 2, 3, 4, 5 carbon chain. So, but it's not that, it is so this is the side chain. In this case, it's an alkyl side chain. But the naming conventions are still pretty much the same. Just a little bit more complicated. So this is our parent chain, or the longest continuous chain of carbon. So 1, 2, 3, 4, 5. So 5 is pent. And this here is an alkyl side chain. So alkyl side chain, and it has 1 carbon. So meth. Not that kind. And when we name this, we name it with this YL, I don't know how to say it. Methyl. So methyl side chain, because it has 1 carbon. Let's practice. So it's slide 27 now. So we use the same rules for naming the hydrocarbons that have one chain, that don't have any side chains on them. So we have 5 carbons. So it's pent, we call it. So it's the parent chain is pentane, single bonds only, saturated hydrocarbon, and we have a methyl side chain. Now there's one more step. So again, methyl. So we count from the nearest end where the side chain is. So if the side chain was here, it would be 2. So because it's over here, we label 1, 2, 3. If it was here, we would go from this end, and it would still be 2. So we then combine the names. So sorry, again, fingers. So we put the location of the alkyl side chain first. So 2 methyl. Two methyl pentane. Is the name that we give that. So 2 is for the location, the parent chain. Methyl is for the alkyl side chain, and pentane is the parent molecule. So that was really short. I didn't expect to get through that as quick. I'll probably add another 4 or 5 videos to explain this, and with some more examples to make up for the short one. But they will get longer. They will go over an hour as we get later on. These are quite simple, keeping it to 1 topic per week, as opposed to trying to get through 2 and rush it and get to an hour. I'll make it up with other videos and later on, and maybe even a bonus week at the end, if I haven't quite made it an hour each week.